Welcome to Spring LIB.
Hi everyone, so what we have here is a rocket that's initially in circular orbit around the Earth, and what we're asked to solve for is to determine the time that's needed for the rocket to travel from the inner orbit at A to the outer elliptical orbit at A prime. So the way that we're going to solve this problem is by utilizing our knowledge of orbital mechanics and the knowledge of periapsis and apoapsis, and also the conservation of angular momentum. So let's go ahead and solve this problem. What we first need to determine is that the velocity at periapsis, so at A. So to move from A to A prime, the rocket we know has to follow this elliptical orbit with RP, which is equal to 8 times 10 to the 6th plus the radius of the Earth, which is equal to 14.4 times 10 to the 6th meters, and our apoapsis, which is equal to 19 times 10 to the 6th plus the radius of the Earth, which is equal to 25.4 times 10 to the 6 meters. We can determine the speed at A for the elliptical orbit by saying that RA is equal to RP all over 2gme all over RP BP squared minus 1. What we can do is isolate BP, which is the velocity at periapsis, which is also at A. So we know that Vp equals Va, which is equal to the square root of 2 times gme Ra all over Rp times the quantity Rp plus Ra. This gives us a velocity at A equal 5,950.6 meters per second. Next, what we can do is we can calculate the angular momentum at this. We can calculate the angular velocity. The angular velocity is equal to Va times Rp. And by using this specific angular momentum, we can see that this quantity is equal to 86 meters squared per second, and this quantity is conserved. What we can do now is determine the period of this orbit and say that period t is equal to pi over h times the quantity Rp plus Ra times the square root of Rp Ra, and this gives us a period equal to 27.9 times 10 to the third seconds. Now the period from A to A prime is just 1/2, or the time required to travel from A to A prime is just 1/2 the period, because we're going from periapsis to apoapsis. Therefore t is equal to t over 2, and that gives us a time of 3.87 hours. That's our final answer.